Good afternoon. My name is Wayne Vold. I'm an Industrial Territory Sales Manager for Global Finishing Solutions.
And I'm Brian Chaudry, a Senior Engineer for GFS. Today we're going to be talking about climate and humidity controlled paint spray booths.
Question asked a lot. Why climate control is required? Who is requesting the climate control for that? Is it the safety people, the paint spec, end user, etc.? Is it temperature required, humidity, and or both of the above? There's a lot of important things that are always asked about that. Is it the data sheet from the paint spec that is requiring that, different things like that, or is it just the customer broadly asking for climate control? And climate control is a very, very broad subject. As you know, Brian,
So the differences in basically having an understanding from the end user perspective on what the true requirements are, and that there's a basis on it, that there's some due diligence behind the temperature and humidity ranges specified for the process. We just need to go down a specific path depending on what those requirements are, and sometimes it may take some time to evaluate the best solution for your facility. So it's important to understand, really what the requirements are of the process.
As a key thing, we need to know where in the United States that paint spray booth is going to go. Is it during just the paint process? Is it during the curing process, and or both? The coating process and the coatings that they are spraying with will give us a lot of that detailed information, along with how many gallons they're going to be spraying per hour and things like that. We're going to need to know them detailed questions to get to the next process of it. Can we recirculation? Cutting that airflow back down on some of these costly projects like this. 20,000 CFM of airflow could be $250,000 air handling unit alone if it's 100% in, 100% out. If we can reduce that and only do it with 5,000 CFM of air, recirculating the rest, it may cut that down to $75,000 air handling unit with the requirements changed to the booth for LEL monitoring, other things that need to be done to a paint spray booth. There are less expensive options out there also as far as DX cooling or swamp cooler, if only cooling is required. So that's the kind of things that we need to get worked out as far as answering properly on the RFQ forms, so we can turn it over to engineering. Maybe Brian, you can touch on the DX cooling and or swamp cooler as options.
Yes, certainly. So with sensible cooling, where we're just adjusting temperature and not really concerned about humidity in the process, you can incorporate DX cooling, which is direct expansion cooling. It's similar to what you have in your house that cools your home. And basically what that process does is it cools the air from a warmer ambient temperature outside, and let's just say 80 to 85 degrees, and would cool it to 75, for instance. So we're just basically taking the edge off as far as temperature, not really concerned about humidity. Another economical way to take a few degrees off higher temperatures is to use swamp coolers or evaporative cooling. Those types of systems are very efficient in high altitude climates and dry climates. So both of those systems offer an introductory level type solution for those processes that require a little bit of temperature control only. So it's done relatively efficiently and cost effectively.
So there again, just adding, in some cases, adding humidity is a requirement. They need, if they're doing some special zinc sprays, different kind of applications, there again, the process and the coatings determines that. And in some cases, they may have to add humidity. They can't get it too low. They need higher humidity to spray a zinc coating of some sort, things like that. There's other applications that's where the product data information is so important and a key factor that we need to know, along with where in the United States, because requirements for upstate New York compared to California, Washington, Texas, they're all different, and the ashrays and different things, and Brian can touch on that with his PowerPoint presentation.
Yeah, so in regards to controlling humidity levels, we could take a look at having an understanding of controlling temperature and humidity within the window. And for instance, if we had a really a basis of understanding that we need from a design standpoint is whether the customer is just looking to have the environment fall within the window. Let's just say, for instance, we're talking about a temperature range of 65 to 80 degrees. That the heating and the cooling system would be sized just enough so that on the worst case temperature day, or the worst case temperature day as far as winter or summer conditions are concerned, that the heating system would be sized to get from, for instance, 0 degrees to 65, or the cooling system designed from to get the temperature from outside air of 100 degrees down to 80, just to get to the window. Is basically what we call falling within the window. And you can take that to the next level with humidity. Humidity works the same way. If there is a specific range that you're looking for, that your process requires, for instance, maybe it's 40 to 70% relative humidity, again, we would size our humidifying equipment to get to 40% on the driest, coolest day that you have. And vice versa, on the most humid day of the year, we would design that cooling and dehumidification system to get you below 70%.
One additional question that did get brought up and does on several occasions was, what's the difference between the modes of climate control aspects for water-based and solvent-based paints? So different coatings and stuff like that. Brian, maybe I'll let you touch on that.
Sure. So yeah, a temperature setting for water-based versus solvent-based paints typically are between 70 and 75 degrees. Really doesn't matter on the coating. Other than on water-based paints, at temperatures above 75, what we found is that users have better results, increasing the temperature of the booth about 5 degrees above the outside temperature. And that's to help burn off the humidity during the high humid days. So, but as always, the first place to look for temperature requirements is the tech data sheets on your coatings. Another question that came in was someone in a humid climate, and what factor does humidity play during curing? And again, with many of the questions related to temperature and humidity, it depends on the coating used. So always check the coating data sheets. A lot of times the coating data sheets will have guidelines on the hardeners and reducers to be used based on what the current ambient conditions are. So they would give you insight as to how much of these additives to incorporate in the coating itself during application, and that will help you during these times. All right, next question we had was, how is humidity measured in the booth, and what is the typical tolerance range? So the type of sensors used typically are there's fixed sensors that can be mounted right in the system. It could be mounted in the paint booth or in the makeup air supply ductwork or exhaust ductwork. That's typically what we do as far as in a climate controlled booth. We have those sensors. So they're fixed, they're rated for the environment in which they're located, which could be a class 1 div 1 area, explosion proof area. So they're rated for the environment, and they have accuracies of plus or minus 2% typically. The other way that humidity is measured is many times paint suppliers have handheld devices that they can supply you to figure out what what the current environment is. So again, you can review that, take a look at how that compares to the ideal conditions and determine what additives as far as hardeners and reducers to incorporate into your paint mix. The next question that we had was, is there a way to add humidity control to an existing booth? And yes, there is definitely a solution, but again, it depends on the climate, where you're located, what the existing system configuration is, and defining what specifically you're looking for as far as temperature and humidity window is concerned. So those are components of the makeup air system typically that we got to look at, and depending on that configuration, we have to evaluate to see if any part of that can be reused or not. Many times, unfortunately, it would require replacing the makeup air component of that system. In summary, if we were to get the most useful information out of this presentation, it would be understanding, again, what the technical specifications of the paint require. So it's temperature range and humidity range that we're looking for. And if you're able to give Global Finishing Solutions that information, we would evaluate it, work with our sales department, and develop a custom solution for your application.
That's all we have today on climate control.
If you found this video helpful, please like, share, and subscribe.